Lesson 14 demo. Today we learn a new derivative rule called the chain rule. The chain rule is used to take derivatives of composite functions, so we'll also briefly review composition of functions. Number 4. I now present a new derivative rule that allows us to take the derivative of more complicated functions, the chain rule. We aren't going to justify why the chain rule works, so let's take it on faith. 5. Let's find the derivatives of the following. The idea here is to apply the normal derivative rule and then multiply by the derivative of the stuff. You're going to hear me say that phrase over and over again, multiply by the derivative of the stuff. Part A, y prime equals, so there's nothing new here. This is just our power rule, 23x to the 22. But let's take a look at part B, which is y equals x squared minus x plus 1 to the 23rd. So as simple looking as this function is, the only way to do it without any new tools is to actually like distribute this thing out, like write 23 copies of it and do an absurd amount of distributing, right? Everything in each parentheses through everything else. And then have some massive polynomial of degree, I guess 46, and then take the derivative when it looks like it's in nice polynomial form. But instead of that, we'll do our brand new thing called the chain rule. So here's what we do. Y prime equals. I'm going to kind of blur my eyes a little bit and just pretend that this is x, because I know how to do the derivative of x to the 23rd. I would bring the 23 down. I would copy the x. I'm just going to leave a little blank there, and then I would put a power of 22. Well, if that property works for when it's just x to a power, then maybe it just works when it's something else, something more complicated than x, like x squared minus x plus 1. So this feels reasonable. It feels right that we would just do the normal power rule, but instead of copying the x, you copy the stuff in the parentheses. And it does work, but it's not as simple as that. At the end of doing your normal derivative rule, which was the power rule in this case, you multiply by the derivative of the stuff. I will highlight the stuff in yellow, and right over here is where we're supposed to put the derivative of that stuff in yellow. So what is the derivative of the stuff in the parentheses? It is 2x minus 1. It needs brand new parentheses over here, and that is the chain rule, and that's the correct final answer to this problem. So you apply your normal derivative rule, and after you've done that and the smoke has cleared, you multiply by the derivative of the stuff, the derivative of the thing that played the role of x. Now this chain rule actually agrees. It doesn't like displace the power rule that we had before. So take a look at this first example we did here. If we apply our chain rule, so we brought the 23 down, we copied the x right there, we subtracted 1 from the power and made 22. What if we decide to multiply by the derivative of the stuff? The stuff in this case is plain old x. What is the derivative of plain old x? It is 1. And so it's not that the chain rule is like, I mean, it's new to us, but it isn't something that that disagrees with our power rule before. The chain rule just generalizes the power rule before. Technically, every derivative we've been applying this semester, maybe we should have been multiplying by the derivative of the stuff. But if the stuff is x, then the derivative of the stuff is 1. And so we didn't bother putting a times 1 on the end of every derivative, but we could have. Chain rule would have said that's what we should do. Let's take a look at C. At the moment, C is a big old cube root. I can't take a derivative in its current form, so we're going to write it as something to a power. 4x cubed minus 5e squared plus 10x minus 1. So what power is the cube root? We know that's a 1/3 power. And now that it looks like some stuff to a power, I can apply my power rule coupled with the chain rule. Y prime equals. So the power comes down. Instead of copying an x, you're going to copy all of the stuff just as it is. Don't do anything to the stuff in the parentheses. Copy it one time before you even think about taking its derivative. Carefully subtract 1 from the power. And then over here, the chain rule says, okay, you're not done. You got to pay for it. It wasn't just x. You have to multiply by the derivative of what you were kind of pretending was x. So the derivative of that stuff in this case, 4x to the 3rd, that becomes 12x squared. Minus 5e squared, be careful here. Don't say minus 10e. That's not right. 5e squared is just a constant. It's just a number. And so the derivative of 5e squared is nothing. It's a 0, and we're not even going to write it. The derivative of plus 10x, that's a plus 10. And then the derivative of that minus 1 is nothing. So that's it. That's the derivative of the original. D. Find the derivative of this thing. So first things first, we got to recognize what is this fundamentally. Is this fundamentally one thing to a power, like one thing to a single power, or is it fundamentally the product of two things? And hopefully we see it is fundamentally a product, which guides us. It tells us we have to use the product rule first and foremost. So no need to even get lost in like what the derivatives are of these pieces until the product rule tells us it's time to do so. So the product rule says, copy the first. The first is all of this, including the 10th power. And then we multiply by the derivative of the second. Okay, so I'm just going to highlight the whole thing, not just the 8x squared minus 3x to the 6, but including that pi power. So now I'm supposed to multiply by the derivative of that thing that's in turquoise. And this is our brand new chain rule. So it says you bring the power down. That's just a number, it's pi. You copy the stuff one time, no derivatives in here. Copy those parentheses once. Then you multiply, or you raise it to the 1 less power minus 1, so p minus 1. But then you got to multiply by the derivative of the stuff in the parentheses. And so we are going to put right over here the derivative of the stuff in the parentheses. Okay, so the derivative of the stuff in the parentheses, that's easy. It is 16x minus 18x to the 5. That needs parentheses, and we're good there. It might be tempting to stop, but we're not done. We're only halfway through the product rule. So what we just did was first times derivative of the second. All of this was the derivative of the second, but the product rule continues, plus the second. We copy the whole turquoise highlighted thing from the top there, including the original power of pi, times the derivative of the first. Let's make this one yellow. So here's the first, and it includes that 10th power up there. So we're supposed to multiply by the derivative of that stuff and put it right over here, that whole thing including the 10th power. So what is the derivative of that whole thing? Well, the 10 comes down, you copy the stuff one time, subtract 1 from the power, but then we're not done. The chain rule says times the derivative of the stuff in the parentheses. So right here, we're going to put the derivative of the stuff in the parentheses. So I see 35x to the 6th plus 2. Mandatory parentheses there, and we're done. There is a little bit of algebra you could do on this one. I'm not going to. I'll just say it, though. You could factor out, there's a big old plus sign separating two terms, one massive term from the other massive term. And both of these massive terms actually have a lot in common. They have a greatest common factor that's pretty substantial. So for example, take a look. Here's a 5x to the 7 plus 2x minus 3 to the 9th power. And here it is to the 10th power. So you could actually take out all 9 of these, and these would all be outside in the front of big parentheses, and there would only be 1 left from these 10. And the same deal here. There's an 8x squared minus 3x to the 6th and an 8x squared minus 3x to the 6th. You can take out pi minus 1 of them. All of these would go outside to the front of big parentheses, and you would have 1 left right there. And then everything else I didn't just sort of underline in blue would just get copied down. Okay, part E. Again, we got to ask ourselves what the main kind of function is before we decide what rule we're supposed to use. I see a square root and I see a fraction. So I know for sure I'm going to use the quotient rule. And I also know that it's a good idea to change this square root into a power. And square roots can translate to powers of half. And so the question is this first a power? Like fundamentally, is this an entire thing to a power, or is this fundamentally the quotient of two things? And hopefully you see that this is a power first and foremost. So we're not doing the quotient rule, not yet, not until the power rule tells us to. Okay, so this is some stuff to a power. The chain rule says copy the stuff, bring the power down, copy the stuff, subtract 1 from the power, and then multiply by the derivative of the stuff. I'll highlight the stuff in yellow. It is this fraction. So right over here, I'm supposed to put the derivative of that stuff that's in yellow. And now, brand new problem is like, how do you take the derivative of the stuff in yellow? Well, that is a quotient, and so we need to do the quotient rule. Quotient rule has a big old fraction in it. The bottom gets squared. I'll do that first. And the quotient rule says bottom times the derivative of the top. Derivative of the top is just 3 minus, not a plus. The top gets copied times the derivative of the bottom, 6x squared. And that's the entirety of the quotient rule. Quotient rule came out from applying the chain rule, and we are done. Again, there's a little bit of algebra you could do. I'm not so much worried about the algebra here. I'm focused on this brand new calculus rule called the chain rule. Okay, one last example here in the demo. Below is a very common mistake in using the chain rule. Let's find the mistake. So here it's asking for the derivative of x squared minus x plus 1 to the 23rd. Okay, so we know we're supposed to bring the 23 down. I see that correctly there, and that 23 becomes a 22. I see that. The derivative, here, take a look, I'll highlight in yellow here. There's my stuff. And the derivative of that stuff is right here, isn't it? That's correct. Derivative of x squared minus x plus 1 is 2x minus 1. And then you can take a look, there's a 2 floating out here. Why is that there? Well, that's the derivative of 2x minus 1, isn't it? Okay, so what's the problem here? This is a really common mistake. The problem is that when you apply your chain rule, you do your normal rule. It's a power rule in this case. You do the normal rule pretending that this stuff is x, but you copy that stuff down one time before you take its derivative. So the 23 should have come down. That was correct. But it shouldn't have been the derivative. It shouldn't have been 2x minus 1. It should have been x squared minus x plus 1. That should be in here. This 2x minus 1 should have been right there. So it should have been, and we actually did this on the previous page, but it should have been 23 comes down, you copy this stuff one time. Don't put a derivative in there. You just copy it as if it were an x. Subtract 1 from the power, and then you do your derivative of the stuff in the parentheses, 2x minus 1. And there's no times 2 at the end of that. You don't just keep going. You're not asked to do the derivative of this thing. The chain rule says do the derivative of the stuff once and only once, and you put it right there, and that's it.